The aim of this project was to create a system for training a Hivemind neural network. This involved making a network that would take in multiple inputs to generate actions for multiple units. The project sought to avoid using multi-agent reinforcement learning to achieve this, and focused on creating a single agent that would be capable of coordinating a team of units to maximize rewards. The game environment was made in Unity, while the neural network side of things was made in Python. Information was sent between the two programs using a socket connection. The game went through several iterations, but still has room for improvement. A more complex environment might reveal more information about how the network training could be improved, but this simple game was enough to determine if the networks were learning, as well as getting some initial observations. Unfortunately, the outcome of this project was inconclusive. There were three different approaches to creating a Hivemind neural network, each with pros and cons, but none of them can convincingly work as a Hivemind in their current state. The unit batch system used one network that would take a single image and produce a single action. When passed a batch of 4 images, this produces 4 actions. It showed promising results to begin with, but because each unit only had access to its own view and the overview of the level, they were limited in how they could react to the other units. This approach was the least developed, but it is possible that with some more work it could produce even better results. Next, the network convergence approach uses 4 convolutional networks that feed into a single fully connected network. This approach was functional and showed the units learning unique behaviors, but overall produced the least positive results of all the approaches. The main problem is related to the fully connected network processing the outputs of the convolutional networks as a batch, rather than as a set of 4 connected values. This is similar to the issue experienced by the unit batch system. Finally, the layer convergence system uses the same amount of layers as the network convergence system, but instead all as part of a single network. This produced good results over a longer training period when compared to the unit batch approach. However, the main issue is that the hidden layers of this system are a lot more complicated to adjust, which made iterating on it more time consuming. My recommendation is that there should be some further experimentation with each system and attempts at combining the best features of each approach to evolve them even further.